Okay, so let's continue on with our lecture. I want to introduce sigma notation. Okay, sigma notation. What is sigma notation? Well, sigma notation simply says it's a nice way for us to write. Let's say I wanted to write up, 2 plus 4 plus 6 plus 10 plus 12 plus 14 plus 16. I could write all of that out, or alternatively, what if I wanted to, do 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, and so on up to 100. I could write out all of that, or I could use sigma notation. So sigma notation says that, let me call this number 1. 1 would be equal to, capital sigma is a Greek letter, I equals 1 to 100, so let me just write this goes up to 100, of I. And this is not I the square root of 1, this just means index, okay? So you're indexing, and this is 1 plus 2 plus 3 plus 4 plus ... plus 99 plus 100. That's what that means. That's sigma notation. Here, if I wanted to do it, I have to be a little bit more clever. I need to use sigma notation like this. Sigma, this is sigma of I equals 1 to, well, my first term is 1. How many terms do I have? 8 terms. So I'm adding up the first 8 even numbers. So this is going to be from I equals 1 to 8 of 2I. Okay? So this is going to be, how do you expand this? Well, this is going to look like this. I start at 1. Okay? I equals 1. And I plug that in, 2 times 1. Then I increment. That means I go to the next number. So now my I is 2. So now I plug that into this, and that's 2 times 2. Now I increment again. 2 times 3 plus 2 times 4. And I keep incrementing. When do I stop? I stop at the limit. So the limit tells me I need to stop at 8. 2 plus times 8. Okay? And that would be it. So what is this equal to? This is 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16. So I found a nice compact way to represent this sum and this sum using sigma notation. Let's do some examples here. Write out the following sum. So here, this is going to be, my k starts at 1. I, k, it doesn't matter what the variable is. So don't get confused by that. In these questions, we use k, we use j, we use I, it doesn't really matter. So k equals 1 plus, now I increment, k equals 2, increment again, 3, 4, and then keep going. When do I stop? I stop at 10, okay? And that's it. That would be the answer. You could leave it like that. So this one, number B, is a little bit more interesting insofar as it's not just k that you're working with. There's a formula on the inside. There's a sequence, and we're asking you to add up the sequence. What are the elements of this sequence, 2k plus 1? Well, let's see. The first term is, if you plug in 1, you get 3. And then the next term is 5. If you plug in 2, you get 5, 7, 9, and so on and so forth. Okay, so these are odd numbers starting at 3. Okay, so let's see what that looks like here. K equals 1 to 6 of 2k plus 1. Again, I'm going to start at 1, and I plug that in. Wherever I see a k, I'm just going to plug that in. So this is 2 times 1 plus 1. I finished. Now I increment. I add an addition sign. And now instead of at 1, I'm at 2. Then I plug that in. 2 times 2 plus 1. Okay? And then you just keep going. Now I increment again. 2 times 3 plus 1. 2 times 4 plus 1. 2 times 5 plus 1. 5 plus 1. And then the last element will be 2 times 6 plus 1. Okay? And what is this going to look like? This looks like 3. Let me group all these terms just so you see. So this will be 3 plus 5 plus 7 plus 9 plus 11. When do I stop? At 13. Plus 13. Okay. So that would be the way that you expand that out. Okay. Let's keep going. Write the following sums in sigma notation. Well, okay, so I want this to be in sigma notation with k equals 1. Well, for me to do that, I need to know what's the expression here. What's the term? What am I summing over? Well, this looks like an arithmetic sequence, doesn't it? From 10 to 18, I add 8. From 18 to 26, I add 8, and so on and so forth. Okay, fine. So that means that this is going to be a sub n equals a sub 1 plus d times n minus 1. That means a sub n is 10 plus d is 8, n minus 1. But now there's a problem. In order to do, I can't just say this. I can't just say, okay, this is k equals 1 of 10 plus 8 times n minus 1. I can't do that. Why? Because there's no limit. I don't know when to end. Well, ideally, I want to end where at 162. That's my last term, so that's what I want to end at. But what number does that correspond to? Well, if a sub n is 162, then that's equal to 10 plus 8 times n minus 1. I can solve for n. I can solve for the highest, for whatever number this corresponds to. Okay? Because this is the first term, this is the second term, this is the third term. But what is this term? This is the nth term, right? So I want to find out what is n. And to do that, you can just set these two equal to each other. All right? This is going to be 152 equals 8 times n minus 1. I'm going to divide by 8 now. So 152 over 8 is 19 equals n minus 1. So I mean that's telling me n is equal to 20. Okay, so the answer for number A is going to be that this is the sum from k equals 1 to 20 of this formula, 10 plus 8 times n minus 1. Okay, good. I'm going to do more examples like this later on. So if you didn't quite get it, that's fine. Let's just move on, and you can check out the subsequent examples. All right, so actually maybe I could do one more. Maybe I can do one more here. Let me erase this. Now I want to do number C. Let's do number C. So this is going to be the sum from k equals 1 up to something of, well, what is this? What's the formula for the nth term in this sequence? Well, from here to here I multiply by 2. From here to here I multiply by 2. And it looks like in general this is a geometric sequence. So it's going to be a sub n equals a sub 1 times r to the n minus 1. And so a sub n is equal to, what's my a sub 1? Well, it's just 1 in this case. My first term is 1. What's my common ratio? 2 to the n minus 1. Okay? So I can't just leave it like that. I can't just say this is the sum from k equals 1 of 1 times 2 to the n minus 1, or k minus 1, because I need to know the upper limit. Well, what's the last term going to be? This is the first term. This is the second term. This is the third term. This is the nth term. But I want to know what the last term is going to be. So what I'm going to do is I'm going to say, okay, a sub n, that's 2 to the 15, equals 1 times 2 to the n minus 1. So 2 to the 15 equals 2 to the n minus 1. That tells me 15 equals n minus 1. So n is equal to 16. Good. Great. Okay. So that means that the limit is 16. Sorry, I almost forgot to do that part. That would be the answer. Great. Great, great, great. Okay, so now we're going to learn two handy-dandy formulas, and let me give those to you now. So let's say I wanted to add up 2 plus 3 plus, let me do it this way. 2 plus 4 plus 6 plus 8 plus 10 plus all the way up to 102. How would I do this? Let's say this is up to 100. I want to add up the first 50 even numbers. This is the first even number, this is the second, this is the third, fourth, fifth, and this is the 50th in even number. Okay. How would I do that? Well, actually, there's a handy-dandy formula. So we say that the nth partial term is given by S sub n equals n times a sub 1 plus a sub n all over 2. Okay? So if I want to know the 50th partial sum, this just means the 50th partial sum. If it was up to 102, it would be the 51st partial sum. But this is the 50th partial sum, so I write S sub 50 is equal to 2 plus, let me just erase this here, 2 plus, what's my, sorry. This should actually be 50 times 2 plus, what's my a sub n? In this case, it's 100. 100 all over 2. Okay. What is that number? It's not so important. You could plug that into your calculator, but that's basically how you would get the nth partial sum. Okay. All right, great. So that's another formula that you have to know for the exam, how to compute the nth partial sum, and you'll do example questions like this in your homework. Okay. There's another formula that corresponds to, you could probably guess, that corresponds to the geometric sequence. So for arithmetic sequences, partial sum, the arithmetic partial sum is given by S sub n equals n times a sub 1 plus a sub n all over 2. Okay. The geometric formula for the partial sum is given by S sub n equals a sub 1 times 1 minus r to the n all over 1 minus r, where r is the common ratio. Okay? So you would use this formula. Let's do an example. Let me insert a slide here. Let's do find the sum of the first 5 terms of the sequence a sub n equals 3 times 2 to the n minus 1. Okay? So if I were to write this sequence out, it would be 3, 6, 12, 24, 48, and so on and so forth. And I want to add up the first 5 terms. I could add them up in my calculator, but just for the sake of this example, I'm going to use this formula. So I know that S sub n is a sub 1 times 1 minus r to the n all over 1 minus r. So S sub n, so S sub 5 in this case will be 3, because that's my a sub 1, 1 minus 2 to the 5. 2 is my common ratio, right? I'm multiplying by 2. All over 1 minus 2. Okay? And that would be the answer. You could plug that into your calculator and you get some number. But generally, that's how you would do this question. Okay? Okay, so let me do this example now. This is 6j minus 4. It wants me to expand this, and I'm going to then find the common ratio, the answer. So to expand this out, this would be 6 times 1 minus 4 plus 6 times 2 minus 4 plus, and you would keep going up to 6 times 10 minus 4. Okay. Okay. Well, what are the elements of the sequence? Well, the first element is 2, and the next element is 12 minus 4 is 8, and then the third, so 6 times 3 minus 4 is 14. Okay. So each time I'm adding 6. So I'm going to rewrite this as a sub j, because I'm using j because that's what the question's using. A sub j will be a sub 1 plus d times j minus 1. Okay? And in this case, that's going to be 2 plus 6 times j minus 1. This is asking me to find the 10th partial sum of this arithmetic sequence. So this is s sub 10, actually. And to do that, I just use my formula. My formula says to do n times a sub 1 plus a sub n all over 2. So that's what I'll do. A sub 1 is 2. 10. This will be 10 times. A sub 1 is 2 plus a sub n will be, well, let's see, what's my last term? It'll be 60 minus 4, which is 54. All over 2. And that's going to be some number. You put that in your calculator, you get the answer. Okay? So that would be the answer. Okay, good. So let's keep going. I want to talk about one more theorem, one more very important theorem. You'll talk more about this in class with your substitute, but I wanted you guys to see me do it. We'll talk about the binomial theorem, so that'll be in the next lecture.